of, okay, here we go. I want to thank everybody for coming tonight to the November speaker series. This evening we have our guest tonight, Paul Maguire, which I'll introduce in a moment. And what I would like to say to everybody going forward, we are planning a December speaker yet to be announced. And at that December meeting, we'll have some information about 2022 speaker series and going back to a combination of Zoom and in-person events at the UMass Innovation Hub in Haverhill, which will start in January. For people who do want to come into meetings at the Innovation Hub, we're going to have them both in person and on Zoom for those evenings. They have that set up at the University of Mass in Haverhill to do that. So people who can't come can still be part of the meetings. So we have a lot of new things happening in 2022 for Invent New England, which I'll be going over in the next few meetings and probably before that. So, well, without further, that's a little club business, which will be continue on. Our guests tonight, I don't want to call them speakers because we've been doing we think a fairly good job with the kind of just sit down and chat with a guest that we have. In Paul's background, which I'll introduce him right now. I'll let him tell you a little bit about himself and his background. And then we're going to do what we normally do is Paul and I, Alexa, will have a little chat. We're going to cover some topics in Paul's field and see how it can relate to everybody who's in these on this event tonight. So Paul Maguire, welcome to the November Invent New England speaker series. Why don't you tell us about yourself, Paul, a little bit before we really grill you tonight? A lot of questions and everything.
I like the pun there, George, with the grill. That's good. That's good. I like that. Hi, everybody. Thanks for being here tonight. Again, as George said, my name is Paul Maguire. I'm actually a New England guy. Originally, I grew up in Burlington, Mass. Went to school at U Lowell and plastics engineering. George asked me to include stories along the way, so I fell into the plastics engineering program by accident when I was looking for a different kind of program, and I happened to literally walk through the plastics engineering program at U Lowell back in 1980. What the heck would this have been? 83-ish. And I had been to a number of schools, and it was the only school when I walked by that there was a cork board, a double cork board with letters from companies saying, send us graduates, we have jobs. Send us graduates, we want to hire people from your program. And it was Shell, and it was Exxon, and it was Tupperware, and it was all these big companies. And I thought to myself, well, if I did this, at least I'd get a job. And that was basically how I sort of accidentally fell into plastics. I was also looking for a technical program. I was good in chemistry, there's a lot of chemistry in the plastics program there. So I figured I could at least do well enough to get by. And that's how that part started. So I graduated 86 from U Lowell. Started right away in medical devices. I started manufacturing medical devices for a company down in Pennsylvania. We made syringes and medical vials and all kinds of medical products. Working in an injection molding plant that ran 24/7. We had 50, 60 presses going at any given time. A great place to learn the trade. Great place to cut my teeth for a couple of years there.
Paul, where do you live now?
I live in Virginia now. I moved to Virginia in 2007, just west of Richmond, in a beautiful little place with a really dumb name called Goochland, Virginia. But it's a very nice place, even though it sounds like I live in Dr. Seussville. So after working in med devices in Pennsylvania for a while, I also worked in research and development, developing new manufacturing cells for that same company, and then ended up in back in Massachusetts after my dad got sick. I wanted to come back back in Massachusetts in the early 90s. I worked then for a number of years at a small company that called Kitty Products. Their brand name was the First Years. If you have kids and you've heard of that brand, they were a small brand out of Avon, Mass, at the time, and I had a really good boss there who taught me a ton, taught me a lot of stuff. But one of my jobs was to help other people, help the other project engineers fix the problems that they were having with plastics and with products that they were developing. We used to develop in the neighborhood of 60 products a year, plus or minus. And we had a running product list of 200 or so at any given time. My job was to fix the existing stuff and help the new guys. And that was also my first time working in Asia. My first trip to Asia was, my first trip to China was probably less than a year after Tiananmen Square. For all those of us who remember that, it was a very interesting time to be a rookie, cutting my teeth in the China trade. Did that for about 3 years, a lot of trips back and forth, a lot of engineering, a lot of product development. Then I went with a small startup company in Massachusetts, also doing med devices. I was the 12th person at this company. And we were going to set the world on fire. We had a great product. It was a fantastic place to work, a lot of energy. We really believed in the product that we were making. It was a fantastic environment. Really enjoyed it. It was the kind of place you look forward to working to every morning. You just got up and we worked late until the night. We had a great crew of people. Many of those people I'm still in touch with. It was a fantastic experience for a number of years. And then it got too big. I learned early that I'm kind of a small company guy. I don't like big companies, never have. The bigger it is, the less I like it. The smaller it is, the better I like it. And my working for somebody else, I've been as small as 2. And now working for myself, I'm as small as 1. So the smaller it is, generally speaking, the better I like it. So as the company grew, I stopped enjoying it so much. But we had a spin-out company that was doing something else. They were doing a breast cancer detection product. And again, with that first group, with that first med device company, and with the second one, really my job was scale up. They had a lot of smart guys who had done a lot of research and development work, figuring out how to do something that no one else had done before. But none of them could do it more than a dozen times. They couldn't make more than 12 or 50 prototypes. In their business plan, they needed to make millions. And my job was to figure out, get it off the bench and get it into the millions of pieces for pennies apart, so that so that the company could make money, because they all had a disposable component to them.
I want to take you back to a couple of things now that you're, as I said earlier, we're going to be taking questions from people during the course of the next about 50 minutes or so. And Lexa will bring those to light when we touch upon something that might hit home with some of our audience tonight. So let me go back to something that you and I had talked to earlier. We talked about supply chain. We talked about short runs are much more popular with products. So our audience tonight, they're creators, a lot of them. Some are service providers. I did see some patent attorneys in the crowd, and I saw some other inventors in the crowd. And so everybody has a different angle on how things go. So your industry, plastics, it's never going to go away. Keeps going. It's never, there'll only be more creations from the plastics industry. And certainly as our worlds change, the ability to get, let's go right into it. The ability for a creator to get a very workable prototype that he needs something out of plastics. right? So when you and I talked before, it was, well, how many they really need? How many they really need to get the point across? And then, I want to touch on your experience with Stasher and had that come about. But just touch on it for a moment. When someone calls you, and I want you to talk about your company there in the background with the sign of, if somebody calls you and says, I need this here, I need one of these, and I have a picture of it, and can you help me? What do you do? What do you tell them right off the bat? And I think we'll get into the degree of crazy of inventors. And I want everybody listening out there that was not my term. That was Paul's term right there that used it for all the rest of you out there that were inventors. I want to give you credit for that term too, Paul. So why don't you start out with just, when you get that first call, because that's the excitement part. You hear it on the other end of the phone, right? Is that I have this and I don't know what to do with it. Do you get referrals from other people? Are you out there so people can find you? Tell me about that.
Everything I've done. So I've been conventionally employed. I like to call it that these days. The vast majority of my career, and have been working for myself and doing my own consultancy, Adept Product Solutions for about a year now. And I started about 3 years ago because people kept coming to me. I've got that skill set where people who know me kind of stay in touch with me because I'm good at problem solving. That's the core thing I'm good at is problem solving. So a number of people over my career would keep coming back to me, asking to help out on problems, and that was part of what Stasher was as well at one time. So most of my all the work I've gotten has been referrals, has been people I've worked with in the past who primarily through LinkedIn or through conversations with other people that that you get to know throughout your career. When certain people found out that I was consulting, they called, my phone started ringing. So right now I'm working with 2 companies in the Massachusetts area who are my larger customers right now, who are both medical diagnostic startup companies. And these both happen to be people I worked with in the 90s at those other medical device places when we were all relatively green engineers, and that place just spurred everyone who was involved with that company has done well, truly, almost to a person. And so these guys are now CEOs and CIOs.
Why do you think that was, Paul? What was about that company that spun off people that could go out then and go it alone, or go on to other companies? And what do you think that was?
It's hard to say. There was definitely again, we were a very small group, we were a very small compact group. There was definitely a feel like we were going to change the world with our product. We did not change the world with our product, but we believed we were going to for a number of years. There was a lot of camaraderie, a lot of pulling together. So I don't really know. It could be they just found the right people and hired the right people, and all those people went on to great things. But hard to put my finger on what that magic sauce was.
Okay, so Lexa just came to you 15 minutes ago and she said, Paul, I have this beautiful thing that I need your help with. So where do you take Lexa?
So it depends. Sure, it depends upon the. So I guess we'd start with the process of exploring what the product is, why they're developing it, why they think it's going to be unique, different, needed in the market. Are they solving a problem? There's a lot of things out there that are kind of tchotchke, that like the world doesn't necessarily need, which is fine. Some people like tchotchke, but it's better not to develop your business plan on that, right? So I will both provide guidance based on my experience on general business, but also tend more to focus on the product, how it could be, what they're looking for the product to do, how it could be made. My hardcore experience lies in plastics, but I'm fairly material agnostic at these days. I've worked in metals, I've worked in rubbers, I haven't worked in wood much, a little bit, but I haven't worked in wood too much. But and then, figuring out what it is that they're looking for the product to do, and if they've got a reasonable expectation of where they're at and where they need to go. Have they built a single one? Have they tested it out any place? I'm big on encouraging people to do a lot of do prototypes for themselves, if for no other reason than to prove out the kinks and prove out the bugs. One of the things that we found great value in with Stasher, and Stasher was a very unique story, and it very much blew up and became a very impactful company. But one of the key steps along that path was we started out working with a lot of independents and boutique stores. Those were a lot of our sellers, and independents and boutiques are.
Let me interrupt for a second, Paul. I'm not sure everyone on the call knows about. Can you give us a tiny bit of background on Stasher and your involvement with that company?
Sure, if you like, I could go there.
Just because I'm not sure that everyone knows, and I think it really will drive home a lot of the points you make, and I want to make sure everybody understands it.
Yep. So for a large chunk of my career in the middle 2000s through the middle of 20 teens, I was working on, and my job was pretty much product development for my clients. We'd get clients in very much like we have a number of inventors who came in, a number of small companies, a number of large companies, and they'd come to us with their product ideas. We would help them develop the product. We would then source the product. Most of the time at that point in time, most of that sourcing was out of China. So when Stasher started out, Stasher was one of my clients. Kat Nori was someone that we met at a trade show. She had the idea for a product. The product became this. It's a silicone Ziploc storage bag, primarily focused around the food industry right now, but has lots of other applications. She had the concept. We didn't start talking with her about this product. She was an inventor. This was her one big thing. She had a different company that made baby products. We talked to her at first about bibs and this and that. And then when she got comfortable with us, and specifically when she got comfortable with me, she told me months later that she had this idea. She'd been working on it, and she conceived the idea. She's the founder of the company. I did not. There's something that they had mentioned. I was co-founder. I was co-inventor, but not co-founder. She was the company. She had the idea for the product, but needed a technical person or needed somebody to help guide her and get the product from sketches and concepts into reality, and to make that happen. And that's what it was. Eventually, I joined her company. She's one of those people who kept calling me at night, and then eventually I joined her company. She had a successful run on Shark Tank. We totally blew up the industry. We were the fastest growing private company in Silicon Valley, because we were located just outside of just outside of Oakland, in Emeryville, California. We were the fastest growing private company, with our growth rate was 1,800% plus or minus.
Wow.
And that included little companies at that time called like Uber and some companies that deliver food, and those guys. There's a lot of tech companies. Those guys are public now, but at the time during this portion, they were still private companies. We just blew the doors off that. We ended up with after a few years of explosive growth, we ended up selling the company to SC Johnson. SC Johnson is the maker of Ziploc bags. Mm-hmm. SC Johnson owns that industry that we were the disruptors of. We found out later that SC Johnson had been trying to do what we did for over 5 years. That they had spent millions and millions of dollars trying to do basically what we did. And at the same time, they never believed that we could do it, ever believed that we could do it. And
nice feeling, huh?
It was a lot of fun at the dinner. So when you have the buyout and you do all that, everybody goes to dinner and rubs elbows and slaps each other on the back, and all that stuff, right? And they told us at the dinner that these are the same people that 2 years ago they were sitting in the room laughing at us, literally laughing at us, going, "No one's going to pay $12 for a reusable Ziploc bag. It's just not going to happen," because they sold them for 12 cents or less. That we were completely crazy. And then 2 years later, they paid a whole hell of a lot more than $12 for a silicone reusable Ziploc bag. So-
But I thought that they were you said they had spent 5 years trying to do the same thing and couldn't do it, but they were also doubting that it should even be done at the same time.
Yep. So SC Johnson's a big place. So their R&D, they did have an R. So not everybody was like real well connected. And one of the things about them is their acquisitions group is largely completely separated from their other groups. And apparently they do that quite purposefully. So there's a lot of insulation there. So those guys weren't necessarily unaware of what was going on with the other groups, and all that kind of came together.
Okay, that's interesting. Okay.
Yeah.
Okay.
And that's, George, also, we were talking before about experts and like when's the right time to talk to an expert and when's not the right time. And my comment, I think to you at that time was, if what you're doing, if the product that you're making is truly revolutionary, if it's outside of what's currently being done, if it has the opportunity to be market changing, the experts that you want aren't necessarily the experts who are currently in that field. And this was an example of that there at Stasher. The people who made the current product were too close to it and couldn't step back from the world and see like a completely different way to tackle the same problem, because they had spent years doing like iterative changes. We'll put teeth on the Ziploc and now it'll make noise, and we'll go from yellow and blue to make green. That was their idea of innovation. All these small iterative steps, and they didn't have the opportunity to really like step back. They were too ingrained in the process. So sometimes experts are terrific particularly if a lot of innovation is iterative. A lot of innovation is, look, camera, phone, put them together. There we go. It's and boom, right? Huge product. So I'm not dismissing an iterative process. But if you have an iterative process, an expert who's currently in the field may well be an asset to you. If you've got a product that's a little bit too much different than what's currently in the field, an expert in that field might be a negative for you. They might not be able to see the vision that you're kind of saying there.
Is that, we go back to the comment about crazy ass inventor about that. Well, I think that's for our industry, Paul, where now you are being contacted by creators and have to kind of walk them back off the cliff sometimes with what they want to try to do or what they can't do, because they don't know your industry. They don't know your expertise on you. They're bringing you something and you say, okay, that might probably not going to work that way, but it will work this way. You can take them to another area and kind of show them the reality of something. They could see how something should work, but you would take them and say, okay, that won't be able to work exactly that way because of this particular thing with the plastic or anything to do.
Yeah. And an example of that, George, may be a lot of people, and I'm a big fan of doing things with rapid modeling, rapid prototyping, SLA, 3D printing, those kinds of technologies have really advanced and really going to help for relatively short money and relatively quickly an inventor to see his product and iterate on it until and make it better. And so much easier to do that when you can hold the product. But there's an awful lot of things that you can 3D print that you cannot make. You cannot mold it. There's a lot of things that if 3D printing is going to be your long-term manufacturing process, and it's definitely rising to the point where it can begin to do that in a number of industries. But if you're looking to injection mold something or to assemble something or to make something in a different way, there's things you can do with 3D printing that you totally cannot do in high volume manufacturing, where one part may need to be two parts and then find a way to join them together because you just can't form it like that once you get into all the intricacies of needing undercuts and needing things to pull and how molds work and all that.
Paul, you think that for creators, when they come, the idea of getting a prototype that they can pitch so that who's ever on the other side of the table can get it right away what that's supposed to do without any explanation or anything like that. So that's what you do. You have to make sure, because you, as you know, you might only get one shot to make this pitch.
You're only ever going to get one shot.
And you don't want something flying out of your hand across the room when you go to do the pitch because it wasn't as close to the golden sample as possible. You and I had talked earlier about so many more industries, well, so many more smaller companies that are really just focusing on short runs. They're just, that's their sweet spot. They're
Mhm.
not doing 5,000 because, as you know, stuff coming from overseas or anyway, you're going to own that for a long time. If half your what comes over from overseas is bad, that's a problem right off the bat. You've lost a lot of money, a lot of time, and things like that. So, do you work with them to try to get them to really understand that they don't need that many, that they just need maybe a few really good ones?
Absolutely, absolutely. The point, you should always have a point or a reason that you're looking to do with your prototype, right? And oftentimes, an inventor might want to prototype two different versions of something to see which one works better for themselves. And while they get to know the product, again, per your point, once you when you're sitting in front of somebody pitching them, you want your one best opportunity right there, right there in front of them. Your comment about a lot of companies looking for smaller volume manufacturing run, that's definitely been an interesting thing to watch in the industry. So a number of years ago, excuse me, a number of years ago, everyone was very hot and bothered to run out and buy a 3D printer. Everybody had to have a 3D printer. That way you can do real fast turnarounds, et cetera, et cetera. It made a lot of sense for some people. It never made sense to me. And my whole career, I never bought a 3D printer, never wanted to. Always saw 3D printing as a service. Always saw it as something you can get somebody else to do. And the technology is still changed so fast in the first 10 years, and it's still changing very quickly, that having a lot of money tied up in a piece of capital that is going to be arguably technically obsolete, in a short number of years, also kind of like never made sense to me. So what happened in the industry is a number of companies who were making SLA machines and rapid prototyping machines began to see a lot of machines come back, or that the industry started shifting to a service-based industry, and oftentimes it shifted to the people who were making the equipment. So companies like Stratasys and other companies who will still sell you equipment, will also mold your parts for you. And they're happy to mold you a small number of parts. And they've now expanded into small, low volume injection molding. And there's a whole field now of companies like that, Stratasys, 3D Systems, GoProto, that can make you an injection mold out of a 3D part. So one of the super expensive part of making an injection mold is making the cavities and the cores and doing all that detailed machining. If you can make those cavities and cores with 3D molded pieces, it dramatically reduces the time and the cost to make that tool. It's a limited life tool. You'll have to replace the tool more quickly. But if what you need is 50 pieces or 100 pieces, these same places that used to be SLA places are now morphing their business model.
Well, tell us what SLA.
Stereolithography.
Okay.
It's one of many 3D printing methodologies. Most 3D printing methodologies involve starting with some type of base material that is then built up on layer by layer. Sometimes that base material is a liquid that as it is with SLA, that then gets cured with the laser as it goes through, and it builds up in a set of layers to make the final product. Sometimes it's a powder, sometimes oftentimes it's extruded, a small extruded thread of plastic that makes a path that then grows up on itself to manufacture to make the part. It's a number of different methodologies that kind of do similar things. Some of them are able to do different materials, and other ones are, etc.
Okay.
So by and large, Paul, if you were, they always talk about prototyping looks like and works like. If you wanted a true works like or functions like prototype, and you were to compare and contrast one that was injection molded versus one that is injection molded the traditional way versus a plastic prototype that was, the molds were 3D printed, what would you say, for just from your experience, do you feel like they're extremely, like, would it be very difficult for an average person or even someone who is an engineer like you just to see the difference?
Really the primary place you'd likely see the difference is on the surface finish. It's going to be on a 3D printed mold isn't going to be able to have that super high mirror kind of surface finish that looks depending upon the product. A lot of times you don't need that kind of finish, right? You're looking for a matte finish. You're not necessarily looking for something like that. But the one place where you would be able to tell something like that fairly quickly would be if you were looking for a very shiny surface finish in order to and for the finished product versus the prototype. Prototypes are hard to get shiny. Minus there's other things you can do later. There's some post molding, post manufacturing things that you can do with vapor honing and with buffing and with painting a high quality. A paint job can help bring out that gloss, put a layer of gloss on there that wasn't there before for both a show and tell sample, a functional sample that also looks good.
And it's probably the life of the product if you're using a 3D printed mold versus one that's traditional.
Sure. So in the 3D printed mold is going to need to be replaced more often. It's also.
But the product itself, would it be just as not just functional but sturdy?
Depending upon the product, yeah, totally can. They can totally
why would anybody
they can totally be products for sale. Totally.
So why would anyone then prototype with anything but 3? I mean, you can't. I can't imagine a scenario whereby you would use the traditional injection molded pieces for a short run or prototype or.
So depending upon the parts get too large. The 3D printed tool kind of idea kind of falls apart, right? So we're talking things roughly that are the size of or smaller than a brick. As a rough, but you can have multiple pieces, right? If you're taking 3 pieces, you mold them on, then you put them together, that's fine. But if you're making something the size of a bread box, a 3D printed mold is not going to work out. There may be materials that you want to mold in that are also not going to work for a 3D printed tool. There also may be some, if you need mold actions, you need a sideways hole in the product. That's not going to work so well in a 3D printed tool. So there's definitely they definitely still have a number of technological limitations. But if you're doing something,
that's changing though. Like
all the time,
and they're getting more and more sophisticated.
Always getting better, right?
Yeah. Oh, I think that's great news for all of us inventors who want to work with plastic because it's cost prohibitive right now.
Yeah. It's definitely a growing field. There's a number of places that are doing it pretty well. And then there's a number of places that are now more focused on doing short run work with modular tooling and opportunities like that, because they kind of see the value of, if they can get it in quick, the piece part cost. If they can figure out a way to offset their setup costs. So that's a lot of times with injection molding, there's the whole process of getting it in there, setting it up, setting the tool up. That's very expensive. So the first part is extremely expensive. The 1,000th part, not so much, right? So where companies can reduce their setup time and their setup costs, they can then bring the cost down, doing things like using modular tools where the whole rest of the tool is already built. Really, the only thing that they're building for you is a custom little piece that slides in.
Okay.
So the framework of the tool, everything else is pretty much already done. The only thing that's unique to you is that little piece, that little insert that is your part. In a number of tool systems these days, you can slide that part in and lock it in place. Make your part. They can slide it out an hour later. Slide somebody else's part in. Make their part.
Okay.
Yeah, that can kind of keep them efficient. And there's a number of places. A lot of the what used to be the SLA industry, but oftentimes even other companies are morphing towards that smaller run stuff.
Yes,
Well,
I think this is. Oh, go ahead, George.
No, I'm just gonna ask you to take it to the next part with, all right, you've met with the inventor, you had, you've made some parts for them. Now you have to explain to them about supply chain or working with suppliers, working with manufacturers. A lot of creators, some on this chat that we have tonight, is that they're not going to be making a lot of these. They're going to look to license them. Do we still have Paul?
I'm still here.
Okay, there you go. Thank you. Very important. I knew when I started, didn't know the terminology, didn't know what to ask for. What I was being told was, in fact, accurate. So when someone comes to you and now you've made them, you made them this, and you said, okay, I'm about to, I really want to license this, so I don't need so many, but you might have another creator that says, I'm gonna start my own business with this. I'm gonna need help with talking with suppliers. Tell me about those conversations that you have with them.
Sure. Suppliers are it's difficult sometimes for suppliers to work with inventors and for inventors to work with suppliers.
Shocking.
Yeah. And this is I think where you were going there on like the crazy ass inventor thing, right? Where inventors relatively speaking,
I want you to know those weren't my words.
Relatively speaking, inventors for a a commercial company is up and making money every day. Inventors can be a high maintenance. They can be a heavy lift for a short amount of return, right? Inventors can sometimes have unreasonable expectations of what's possible to do, oh my gosh, the unreasonable expectations are really like very long of what they might expect from a molder or from a commercial factory. Factories can very quickly and this is one of those things that sometimes people come to me for, because factories can very quickly sniff out if you know what you're talking about. So when I call a factory, I get a different kind of response than if a first-time person calls a factory. I know the questions to ask. I can very quickly establish my credibility, and we can have a conversation on kind of a different level. And I'll also know at the same time, I know if they're bullshitting us, or me. I know if they're telling me something that isn't true, and we should perhaps move on to find a different factory. But at the same time, a lot of their hesitancy is scar tissue. A lot of it's well earned. A lot of inventors can have, again, unreasonable expectations. One of the big things inventors almost always fail to do with their suppliers is to fully define their product. I work a lot of my customers with them on, and it's a very painful thing. This is the from a product standpoint, this is the version of doing a family budget, right? You all know you should have one, but almost none of us do, and we hate it, right? So right. The equivalent of that in product development is a product specification, is knowing exactly what you want your product to do, and writing it down and getting agreement that everyone understands that this is what the product is supposed to do. But doing so prevents so many problems later on. So oftentimes issues that crop up that are common is, it looked great, it worked great, but I dropped it and it broke. And the manufacturer is going to tell you, you never told me you wanted to drop it. What drop test would you like? We could have built that in. I would not have selected this material maybe if if there's a number of I put it in the dishwasher and it warped. Well, you never told me you were going to put it in the dishwasher. Why did it's not a kitchen product. Why would you put it in the dishwasher? Oh, my wife puts everything in the dishwasher. Whatever the situation is. Oftentimes when customers will get that first product back from that first injection mold, that first run, and they're so excited, and it doesn't fit in something, and you never told the manufacturer what it needed to fit into, or you never gave them the mating part that it needed to mate with. They would have found that problem very quickly and worked with you to resolve it before you had 100 of them, or you have 1,000 of them, or you have a garage full of them. And this is one of the big risks with working with overseas in particular, is by the time you get it in, and by the time you got a lot of them, when you discover these problems that are as much, miscommunication issues as much as the inventors, in their mind, they know everything that they wanted to do, but they rarely write it down. And this is one of those places where 3D printing actually doesn't necessarily help. In the old days, you'd do a 2D drawing on an old-fashioned drawing format. You'd have tolerances written out. You'd have up in the corner, for all those, anybody who's an engineer in the crowd, up in the corner, you have a whole series of notes discussing like what the product is, what material you want it made out of, what it needs to do. All that kind of stuff was very standard in making products when you were just defining them on a conventional on a drawing board. That was the way you did it. And these days you can it's easy to skip that and just go right to the 3D design, get a product in. It seems to work, that's fine, but you're not over flexing it. The inventor sort of needs to consider foreseeable use and abuse. They need to consider, not only how is this going to be used, but how is someone going to misuse this? Are they going to put it in the dishwasher? Is it going to regularly get dropped? Things like everything, almost all of that can be accommodated in the product development process, but not if it's not discussed. And the supplier is not going to be responsible for a problem that you never told them to avoid. A performance aspect that was always in your mind, maybe, or maybe it wasn't. Maybe you never even thought about it, and then like, oh crap, it doesn't do this one thing. Well, of course it should do that. Everybody should. It's obvious it should do this one thing. Well, it might not be so obvious, and if it didn't get written down, so the process of discovering and writing down what is your product specification. Again, it can be a painful one to go through because it's not fun. And it really requires you to think outside the box a little bit of your product, but at the same time, so on Stasher, I wrote for the product a full specification that included what's the strength of this when we pull it apart. What's my force? I can eventually get this thing to tear, right? It tears at a rate that's at a force level that's acceptably high to me. But we defined what that was, and we worked it out with the factory, and the factory can hit it reliably. And they know it's important to us. They test for it on a regular basis. Other aspects of the product, the clarity of the product. We have a specification in regards to being able to put a sometimes these are simple solutions. We have a printed a word-based printed template that we put behind the product that you still need to be able to read. Right. Clearly, and if the product is getting too cloudy and you can't, that's our test for that. But if the product came in and it was too cloudy and you couldn't see the food in the package and you expected to see the food in the package, now all of a sudden there's a problem that may have been obvious to the person who was thinking about it, but wasn't obvious to the factory, and you never told them about it.
Well, let me ask you the point. So that's attention to detail when you're getting down to with the manufacturer.
Yes.
I want to take it back now. Do you say that you work with more people bring you a patent with a product, right, that they've developed? They've did the attention to detail with an attorney to get that product through the patent process, which, as you know, is very difficult. And now they come out with a patent for a product and they bring it to you. And they've spent all this time with the attention to detail and now about how they want to make that particular thing, because they might have a very old, a prototype that they made themselves. So you're saying maybe the same attention to detail that went into getting the patent should go into the supply chain with the manufacturer and things like that?
Absolutely.
Okay.
Yep.
I want our guest tonight to I want to take them in your world of the process. They've just created something and now they bring it to you and hand it to you, And then you try to educate them on what particular part that they're going to need now to do this. And that's attention to detail that you need to work with, a manufacturer, long or short run, to get them as much information as possible when
So-
what that is.
Paul, when you work with, we have a few questions that have come in, and we typically wait until like 8 o'clock to start, but I can jump in a second because this is a really couple good questions here, but I just wanted to ask quickly. It seems to me that your role is, you have multiple roles, but one of them is almost like a business analyst, in that you're translating an inventor or a small company or whoever you're working with, their requirements into a manufacturable vision. So am I right in thinking that?
Sometimes, yeah, it's kind of all over the board. It's a
Sure.
pretty wide spectrum of people who hit me up, but yeah, go ahead.
Sure. In this particular instance, though, if we're talking about this, being able to define in great detail what a product should do, and you're talking about handing that off to the manufacturer, to me, that seems to be like maybe the biggest undertaking that an inventor has in dealing with a supplier. So how do you help the inventor? Because I don't know what I don't know. So I don't know to tell the manufacturer about X, Y, and Z. But from your experience, you know that certain things are important that I wouldn't even think of. So how do you draw all that information out of a creative type or an inventor who just knows, I solved a problem and this is the product that solves the problem? So how do you get started with someone like that?
So it is a kind of a wide
Be
field.
kind now, you have a lot of inventors watching this.
It's kind of a wide spectrum of folks who I've worked with in the past. Some of them are literally napkins, and some of them are people who have completed their patent process altogether. One of the ones I'm working on now that we're just about wrapping up and launching introduction came to me as this enormously kludgy prototype that he was going forward with a patent on, and it was never going to be a product. It wasn't anything that you could do as a consumer product. And I worked with them over a variety of time, and I'll bring in to work on projects people with expertise that I don't have, including like industrial designers. So I've got a number of industrial designers that I'll work with, and industrial design can be a really important thing. They're different than an engineer, and they have a really important, they can have an important role depending upon what the product is, particularly for a consumer product. But we took his 3-part globular design idea that looked a little bit like the space station, where you like attach pieces to each other because each one of them did something different, and we brought it into one cohesive single product that had a number of different features on it. But at the end of the day, I can't show it to you because it's not launched yet, but at the end of the day, it's a good looking consumer product, very different and much more functional than the product concept that we started with. So in that case, it was a little bit longer of a path, and we brought in we brought in an industrial designer to do the work that I'm not necessarily as good at. And then I worked with the sourced the manufacturer for him. We got tools built. This one did happen to be built in China. Got tools built, and got through the debug process, and we're about ready. We're about ready to launch, and now we're stuck with the whole supply chain problem.
Okay.
There's also a number of other problems going on over there right now with materials and what have you. But yeah, that was kind of a more of a stem to stern kind of product. But the guy I worked with was super motivated, very much into his product, taught himself how to do 3D CAD just so he could do this. He spent nights and weekends teaching himself how to do CAD just so he could develop the parts. He had done some 3D parts, super kludgy, got the idea across. That was his version of proving that the product could work. And
Sure.
then we made it. Then we took
Into
that made it into a finished good.
Well, I think this is a good time to ask one of these questions that have come in, because I think it's sort of dovetails nicely into it. Bob asks, please compare and contrast the availability of manufacturing in the United States versus China and other foreign countries?
So availability, I worked in China for on and off for 30 years, plus or minus, maybe a wee bit less. Again, since Tiananmen, a little after Tiananmen Square, so I guess it has been 30 years. China earned its place in the world of manufacturing. They have been over the years. They're no longer the least expensive place to manufacture. You can find they're no longer the lowest labor rate in the world. They're not even close to being the lowest labor rate in the world, as they once were. But their efficiency, what you get for your dollar, is extremely high there. They've come great. They work really hard. They're the only place I've worked with that not to get into like nationalities and things like that, but it's the only country I've worked with where the level of work ethic really matches the level of work ethic in the US. They can be very dedicated, very hardworking, very focused on finding a solution to the problem. And they've gotten over the years they've gotten very good at it. They're also can be very easy to work with, and I could contrast that with a lot of U.S. companies. U.S. companies can be really difficult to work with. U.S. companies can be, particularly if you don't speak their language or that you don't have any kind of like gravitas going in the door. They can be difficult to work with. U.S. companies are difficult for, in Asia, I can get something in 6 different colors. It's not that big a deal. Here, 6 different colors is 10,000 pieces in each color. Each color is a color change operation with a new setup cost for cleaning out the machine, et cetera, every little thing. There's generally a lot more flexibility. And I love American manufacturing. I started out doing American manufacturing. I want to do more American manufacturing. The work I'm doing now with the medical device companies up in Boston area, we're all doing that all in the US. But typically a US factory can be much more difficult to work with. When I say difficult, I mean less flexible, a lot of upfront costs. A lot more upfront costs to the point of being 8 to 10x more. I mean, it really makes it a no-brainer for a lot of companies, a lot of other people that are like, I can't, the U.S. companies just aren't being competitive on this relative to the cost of tooling, the cost of what it takes to get what it takes to get things done, and how difficult it is.
So it's not a want-to issue. It's more that they just haven't perfected it or maybe not perfected it, but the efficiency level just isn't there because they haven't been doing it as much or as long as the Chinese counterparts. It
used to be a don't want to. It's largely no longer that. I think the contract manufacturing model is less a piece of American manufacturing history than it is in China. A more typical American company will be a manufacturing company, and we're Ford. We make cars. We own factories that make cars. We build tools that make cars. Where all throughout the last 20, 30 years, a lot of the industry has shifted, and there's a number of companies. Apple does not own a factory. They've got real good relationships with companies that do own factories, and they're really good at developing new technologies and then giving it to their factories. But largely, Foxconn makes their products. They don't own their own factory. They're about the most valuable company in the world. They don't manufacture their own stuff. So in the US, I think it was more that mind shift of using a contract manufacturing, and for factories to kind of like become contract manufacturers as opposed to making their own stuff. And when you make your own stuff, it can be really hard. Running a factory is a difficult thing. When you're doing your own product development and you're an injection molding company, you develop injection molded products. That's what you do. You don't necessarily develop products that the market needs. You don't develop products that solve a problem. You don't develop, what you're focusing on is developing a product that will fit in that machine I got over there. You're not focusing on the market, the problem, the consumer, that kind of thing. You're really focusing on what can I make this thing make? And I think in the US, there was just less focus on contract manufacturing at a time when the industry of product development kind of went contract manufacturing, in part because it's a lot less startup cost. You don't need to buy 15 injection molding machines to get into the business. You
Sure.
just need to, typically you buy your mold, but you don't buy the machine. The molds are expensive enough.
Sure.
I want
So-
to, I'm sorry, Bob, I want to, Paul, I want to let, Lex, should we let everybody back in now for, so bring everybody's camera back on at least? We're at the
Sure.
8 o'clock hour. I know we have some more questions there, Lex, too.
Yeah, we do.
You wanna
I-
get to?
I'm gonna ask Rock's question, and Rock, if I get this wrong, I'm not entirely clear what you're asking, but just chime in and let me know. But Rock asked, what's your sense that management of, I'm assuming, larger companies may hold back inventors versus the entrepreneur who continues to push forward? I'm not sure if I read that the right way. Rock, why don't I'm gonna unmute you and you can ask.
Yeah, that's pretty much it. I think you captured the context. I was just kind of curious what your experience has been when you had talked about the company that had been working on that project for nearly 5 years and wasn't able to bring it to market, but yet that single individual was able to come up with an idea that just proved to be a winner. So I was just sensing that there may be a lot of doubters, if you will, in the management circles that really inhibit a lot of this type of kind of growth that can come from people's ideas that might be working within companies.
You're absolutely correct. There's a lot of it's less the not invented here. It's more, and I think as a country, we're kind of working our way out of it, and a lot of big companies are working their way out of it. But there's definitely still I'm trying to avoid the word arrogance, right? But this is definitely the vibe I got from the SCJ guys when I talk with the SCJ guys. But that they know the industry, they invented this product. They are Ziploc, damn it. They own 75% of this market, and they know everything there is. And my goodness, you wouldn't believe the marketing research we saw from these guys. Oh my stars, it was fantastic. I couldn't believe how in-depth they were able to go, but how with all that encyclopedia of information, they couldn't outthink themselves. They couldn't think themselves out of a box, right? They were too close to the problem. I think the old adage is, if the same people who got you in the problem are unlikely to be the problem people to get you out of the problem, right? And that you kind of need to be open to looking to outside the industry, and that doesn't and it doesn't happen. It's really the kind of the history of small business in America, right? Is that a small company comes up doing something different in a niche area or in a different way that another company's already in, and then they grow it and blow it up, and then the other guys turn around and they go, oh my God, we should be doing that, and they buy them. Right. That's truly the history of it. But I think you're spot on in the fact that in corporate America there can definitely be, particularly if it's a history, it's an industry that is based on or has a long history of iterative improvement. Again, going from the Ziploc bag that doesn't make any clicky sounds to one that makes clicky sounds, and one that has no colors to one that has a little bit of color in it, so you can get the things like things like that. They're too far outside. So one of the big things that we had to change, and one of the things, remember I mentioned that if you've got injection molding machines, you look for things that fit in your injection molding machine. When you make a Ziploc bag, you extrude a film, you extrude a lock, you put the two things together. It's a melt bonding process, and it runs at 1,000 miles an hour. And it's this continuous stream process that runs that runs that product. One of the big problems that they would have had is they couldn't use any of that equipment. They couldn't use any of that knowledge. They couldn't use anything, because the product we came up with, this is a batch product. I make the front half and then the back half, and then I put them together. I make it, and it goes slow. We can make them fast, but it's not a continuous process. It's a batch process. We can get the batch size down very low so that it almost resembles a continuous process, but it's not a continuous process. And it's not a product that you can do a melt bonding on. And those things, I think, were too far outside of the paradigm that they were in, that they could see something like that, working for them. And even now, they're still working on a lower cost version of Stasher that they're going, that may or may not, I can't say too much, that may or may not be out sometime in the future. And they're still doing it outside. They're not doing it they're not doing it internally because they, it doesn't take advantage, it doesn't springboard off anything that they already know. And they've really, it's not like admitting you were wrong, but you're admitting that, like, and if you want to do something very different, you're going to have to make it in very different ways. So
Paul, you bring up a
you're
good
exactly
point.
correct that sometimes I can't see the forest for the trees.
Yeah, you bring up a good point in the sense, if you don't mind me just asking real quick, that it isn't just the product itself that may prove to be a winner, but it might be the thinking along the lines of, what material might go into that product versus one that, is a lookalike versus, let's say, the process of manufacturing. So there are like key questions around the idea of what are the success factors that people would really want to step into or consider, around the ideas of form, fit, and function for your product that might be distinguishable between what you have versus what someone else is already doing.
Yeah, and it's in answer to that question is both very general and very specific, right? So it's gonna be very specific based upon what individual product that it is that you're talking about. But the very general thing is, are you solving a problem? Are you providing a way to do something easier, better, faster, cheaper, or a way to do something that's currently not even capable of being done? Or are you, is it such a small iterative change that it's not going to really drive people to it, and or you could easily be replicated by somebody else if you did get traction on it, et cetera. So, a lot of it boils down to that. But eventually, effectively, you've got to, the product has got to be delivering a value or a service or a feature or an experience that competitive products can't do right now.
Right.
Paul, we're
Thank
gonna,
you, Paul.
thank you, Rock, for that question. Lexa, we want to put up Paul's information if we could. I don't know if we had a slide for adept contact information. We want to make sure we get that, as we call them, shameless plugs. So,
I can grab that slide and I can definitely send that out to everybody.
I'm putting in the comments right now.
Okay.
thank you,
And
Paul. Yeah,
then-
we want, go ahead, Lex.
Yeah, there's another question from Peter Carr that
My email contact is in the comments if anybody wants it.
okay,
Great. Thanks, Paul.
perfect. And I can send this out to like a post meeting kind of thing and include any information like your phone number or whatever. But
You can find me on LinkedIn too. You'll see a lot more about me there.
yep. Peter asked, what 2 or 3 countries would you suggest besides the United States and China? I'm thinking of Mexico or Vietnam. Do you have any suggestions around this?
Vietnam's interesting. I've done some work in Vietnam in the last few years. COVID really has been put a clamp down on that. It's a lot of people looking there right now. The big issue with Vietnam is they are, in my estimation from working with them, they are where China was 20 years ago. Technologically, a lot of their product, a lot of their materials, all that kind of stuff, still their supply chains still feed back into China. So they don't have a lot of steel mills. They don't have a lot of electronics industry. They don't make their own fabrics. They don't, so a lot of, while you're working in Vietnam, a lot of the products that they need to source to come to you are still coming from China. And that's pretty much true in a lot of Asia. Personally, I'm interested in 3 places. The first one being the United States. I think this is a huge opportunity. I think a lot of American manufacturers have learned painful lessons from what's gone on in the last 20 years, and are ready and poised to do better for their customers. And I think that the pandemic and all the supply chain problems, my belief is supply chain issues are going to continue at least for another year. before this whole thing gets resolved, and then by that time there's going to be so much more pent up demand that it's going to remain being difficult. So I'm also kind of negative on the whole U.S. China relationship thing, right? The idea with working with China for 20 years was that they came into the family of nations and worked and came in as a responsible member of the family of nations, and really they're not, right? They're much more adversarial than was ever hoped for, and I think that realization is finally beginning to set in here in the last couple of years. So I'm relatively negative on China as a solid long-term play. They're fine short-term play, they're fine medium-term-ish play, but I'm worried about the geopolitics that gets into there. Places I am interested in is Singapore and from Singapore into Malaysia. Singapore they're easy to work with, very bright. A lot of times, a lot of the work I did in China was out of Hong Kong, where Hong Kong companies that then worked with factories or owned factories in southern China. Hong Kong was a British colony for until 1998. There's a long history of a British system of education and of bilingualism there, so it's really easy for a U.S. person to communicate with someone in Hong Kong, who then can do the communication with someone to someone at the factory, etc. And I see Singapore having a similar opportunity with factory work being done in Malaysia. Singapore, if you're familiar with where Singapore is on the map, it used to be a Malaysian city before it became its own little city state. After World War II, a lot of highly educated, very smart people in Singapore. A lot of the language issues really aren't an issue there. A lot of money a lot of rich people in Singapore own factories and other places. So in Asia, that's the place I'm kind of interested to look. And the other place in this hemisphere, it's really Mexico and Costa Rica.
Costa Rica.
That's interesting.
Yeah, Costa Rica's made a lot of inroads in particularly in medical devices. They're more stable. Their workforce is generally better educated. They're working their way up. So those are the two places. I'd love to be able to throw Puerto Rico in there, but Puerto Rico is just still a mess.
Yeah. Thank you very much.
Sure.
Just a quick follow-on with Malaysia, what's the level of sophistication vis-a-vis, like maybe in terms of efficiency and process and that type of thing, if you were to compare Malaysia to China? Because you had mentioned Vietnam is like 20 years behind. Where's Malaysia?
Malaysia's probably close to like 7 years behind, but they get a lot of they have the support system that comes from people who live in Singapore, who can bring that knowledge based portion when it's needed.
Okay,
Yeah.
Gotcha. That makes sense. Bob asks, I have the impression that 3D printing can use many kinds of materials. Is this correct?
Yes. Yeah, the new technologies are all over the place on that. If another plug, if you're interested in 3D printing, I assist to run an inventors group in Richmond. Our talk this month is on Wednesday, and it's with a 3D printing expert who out of Stratasys, who's like very much cutting edge on everything that's going on in the industry and how it works. He's also the individual we have talking while he works at Stratasys now. He's a former inventor himself, a small businessman, etc. And we'll be talking in depth on a lot of the new technologies that are there. But even a lot of these, if you're looking to get educated on that, a lot of these bigger companies, Stratasys, 3D Systems, a number of them, on their websites is like a whole set of like education pages that'll tell you this is the process, these are the materials that are available, this is kind of like what it's good for. If you're looking to do this, then you're going to want to use this process. If you're looking for that, some of the more interesting stuff has been done in elastomers, where you're now able to get more soft touch materials You're able to get some materials that are over molded, so they have a soft touch outside and a harder piece on the inside, for flexibility and what have you. So there's a lot of interesting things going on, including in metals. A lot of interesting things going on in metals for rapid prototyping as well.
Cool. Cool.
Oh,
How do we learn more about that, Paul? What's the Vine? It's Vine that you are the.
Sure. Yeah. It's the Virginia Innovators Network. We're on Meetup. If you look for Virginia Innovators Network Richmond on Meetup, you'll find us. And it's an open group. You can just join right in, and you'll see the link for our talk on Wednesday. George, my job is your job. And then we have a different guy who's going to be doing the talking. So yeah, I've been involved in that group for going on 8 years or so now, because again, small inventors have always just been near and dear to my heart. That's just that's my passion.
Paul, thank you for that. That's good intel. And as the inventor groups around the country come onto being organized under the UIA, be able to share speakers and information, we think is going to be just a big step up for a lot of our members and future members.
They can hit things.
And future young innovators reaching down into grade schools and things like that with more things. I think that that part for what we all do here sometimes and what you do, kind of gets lost in the shovel. We have to bring the next generation along of learning things. So, appreciate your work on that. I think I had something really good to ask you, and I can't remember what it was now. But I'm sure I'll remember about midnight tonight.
You'll remember the moment you hit the X button.
Oh,
that's what happens to me.
Yeah, I want, the last thing that we had talked about before we came on, and which happens to, and we get to know a lot. I had the occasion of talking to someone recently who wanted to go out and buy a 3D printer to try to do some of the products, for himself. And we kind of guided them to, a local university. And the university was the University of Mass in Lowell, University of Lowell. And to go to the campus, and you might have some graduates thanking for the cup there. And see if somebody on campus wants to take on a project.
Sure.
Rather than go and buy a 3D printer and have to get the materials for it and learn how to use it. I'm glad you brought that up, is that there are a lot of resources that you can sometimes get students.
Sure. That's an excellent point. I'm one of the folks I'm working with now here in Richmond. I recommended to him that Richmond has a large arts school called VCU, Virginia Commonwealth University, which I'd never heard of before I moved here. But they're one of the largest public schools that's also an arts university on the East Coast. Fantastic program. Have all kinds of programs there, including a soft goods and a fashion design program as well. And the product that a client of mine is working on involves attaching a fabric and attaching a plastic together. And he's got a good idea of what he wants the product to do, but like having an industrial designer can really make your product look professional and look attractive to a consumer. Similar thing with somebody who knows their way around soft goods. A soft goods designer can really add value to that. So what we talked about was him, meeting, finding a professor to meet with, generating a $1,000 prize for a student, having that professor run a student contest where different ideas could be submitted, and he could select a winner from that, and then utilize the design from that, and that brings to him a different design skill. Skills like that are also available in places like Fiverr and Upwork and places like that. A lot of graphic designers, a lot of software design, a lot of product designers, a lot of people have SolidWorks at home. Be happy to work on your project if you can describe it. If you can describe it in well enough form and can do so quickly, professionally, and inexpensively.
I think that's, well, we advised that person to go and try the university rather than pick up a printer yourself and try to, 'cause that just leads to frustration, not being done right, and a lot of wasted time.
It's very for me, it's very similar to a sewing machine, right? If what you want to do is like learn to sew and you enjoy sewing and you enjoy 3D printing and making lots of pieces, and you want to make your own chessboard with your whole family face on it and all that kind of stuff, get yourself a 3D printer, have fun. It's kind of a hobby. If what you want to do is develop your product, the 3D printing is one small part of it, and it's a part that your objective is to, it's kind of like golf. The objective of golf is to play less of it, right? The objective with 3D printing is basically the same thing, right? You want to get to the answer fast so that you can then move on to other things. I've in the past, I've considered a number of times I've been asked to purchase one for companies that I've worked for, and I've told them no, that it doesn't make any financial sense for the company to go out and do that, because it's available as a service so easily and so quickly. And so, and the technology is changing so so much that what you're able to do today is a world different than what you could do 2-3 years ago, and will be a world different than what you can do 2-3 years from now still.
So you last in
Joe, to answer your question, yes, absolutely.
Advice to the next inventor that calls you up or emails you, what should they have ready? What do you think they should have ready to talk with you that makes it easy for you to understand what they're looking for and what kind of help they're going to need? So if everybody here can pass on of themselves saying, well, I'm going to call Paul, but how can I be prepared when I call him?
Mostly know what you want to do and be able to be focused on the product. So many inventors I work with, a lot of the early part of it is getting them to focus on the product, getting them to in the early days, you really need to make sure the product is fantastic, that you've considered how it's going to be used, how it's going to be abused, what the consumer is going to do, why it solves a problem, why this product is going to be better than any other product out there. And if it's not, don't do it. Move on to a different idea. Eventually, when you get the product right, you then transition into like your pitch mode and then your marketing of where you're going to be able to sell this product and how you're going to market. And a lot of inventors crash right there. A lot of inventors are inventors; they're not marketers, and they also get very tight to their product. So when they meet somebody who might be able to help them on the marketing and sales side, they don't want to make any accommodations for it. They don't want to add a feature. They don't want to change a color. They don't want to make the product. They don't want to listen to someone else's experience regardless of how the product should be in order to sell the product, because they're so tight to it. It's been their baby for years, and they don't want anyone else to mess with it. And basically, it's going to stay just like that. You need to, you'll be able to take input from other people. One of the interesting things about Stasher was it was just the opposite. Kat, the founder of the company, she was a fantastic marketer. She did social media. She did all the downstream stuff that most inventors do. Most inventors don't do well. She did fantastically. I mean, it was amazing to watch. And what she couldn't do was manage the supply chain and engineer products. And she had the good sense of, when we talked about experts and when to bring an expert in, when not to bring an expert in. A lot of it is recognizing your own skill set, what you're good at, and recognizing what you're not good at. When you find somebody who can do it for you and do it well, leave them alone. And that was very much our relationship there. And the further I got Kat away from the supply chain, the better things went. because she rubbed the factory the wrong way, the factory rubbed her the wrong way. It was just, she had a lot of inventors had that little bit of crazy, successful successful small entrepreneurs are always a little bit crazy. The trick is not to be too crazy, right? But if there's
Right.
not a little bit, if they're not at least a little bit crazy, then they in my experience, they're lacking a passion they're going to need to push them through to make them to make themselves successful. So a little crazy is okay. And Kat was a little crazy in a lot of ways, but on the supply side and the engineering side, she had completely wrong expectations of what could be done, and it set up for conflict with the manufacturers that I had to that I had to fix when I got there. But we fixed it. We fixed it pretty well.
Lex, we cover everybody's questions, I hope, out
Yeah.
there. Can you bring everybody back on so we can see everybody's picture?
Yeah, everyone just,
Everybody want to click back on your cameras? Here we go. We want to see if anybody's sleeping out there. So Bob, you were the only one not sleeping. Joe, you weren't sleeping. See. Antonio, I know you were catching some winks there while your camera was off. I know. All right, everybody else, I guess, wants to stay in the background, which is okay. I want to thank everybody tonight and thank our guest tonight, Paul Maguire, who was so kind to share a lot of his insights tonight. I hope that you will be able to contact him if you find that you need his services or just need to run something by him. Paul, really appreciate your time and thank you for putting in your contact information in the chat for everyone. Really do appreciate that. Lexa, you always have the nice closing. I'm going to put it right on you to do the closing.
yeah, no, just appreciate your time, Paul, really. I thought this was excellent. And I personally, as an inventor myself, had learned a lot from tonight. I've always shied away from plastics in terms of other ideas that I've been thinking through, but now I feel like I've opened up a new world, because now I feel like I can take the licensing route and have it be, relatively cost effective in terms of coming up with like a really good prototype. So I'm excited.
Thanks for having me. I've enjoyed the talk, and I hope it was people found it informative. Again, happy to help anybody out who
Can I say something to
looking
Paul?
for it.
Can I say something to Paul?
Sure.
I wish you would pass something on to SC Johnson about the Ziploc bags. There's Ziploc.
They don't much like to talk to me anymore.
Their Ziploc bags are not watertight. If you
No
put
kidding.
something wet in it, they always leak.
Try a stasher.
Stasher.
Try to stash
Yes, I
it.
am going to. I'm going to look for them next time I go to the store.
Well,
I put a link to stasherbag.com.
Yeah, it's
I
stasherbag.com.
saw it and I already bookmarked it.
Okay. Well,
Well-
thanks again. This video will be available on our YouTube channel. I'll be sure to send out a message to everybody so that they can rewatch it or send it on to others who weren't able to make it tonight. But again, thanks so much, Paul. Really, really, really good.
Glad to be here. Thanks, everybody.
and thank you, everyone. December 13th, the second Monday in December, we'll be announcing our next guest for December. And we will be having a members only Zoom meeting for Invent New England to go over things for 2022, probably the week before that. So please look out for an email from myself, Alexa, to go over that. We have a lot of things to go over for Invent New England and some exciting things for next year coming up. So I want to thank everybody. You know how to reach us by email, certainly. If anybody has any questions about tonight, about the recordings, we can get in touch with myself, Alexa, for that. And I wish everybody a great rest of the week. Stay safe and keep inventing.
Thanks.
Thank you.
Okay. Thank you,
Bye,
Paul.
everyone.
Thanks, everybody.
Thank you very much. Bye-bye.
Really enjoyed it.